Hey guys, it's Miss Riggs here. Um, Last week we talked about population changes in animals and other organisms, and today we're going to talk about the human population. And so, human population change is a bit different. We have a lot of different resources and different ways of manipulating our resources that other animals don't necessarily have. Um, so, our population growth doesn't exactly follow the same rules at least this at this point in our population, as other organisms do. So let's go ahead and get into it. So what we're going to talk about today, we're going to talk about how the size and growth rate of the human population has changed, specifically over the last 200 years, because that's really when it's started to grow exponentially. We're going to talk about why that is and what has contributed to that exponential growth. And then we're going to define four properties that scientists use to predict population size. So, how do they study population? And then, how do they make predictions about these population trends based on ages of the population? And then, we're going to talk about why different countries may have different population growths or different stages of that demographic transition. So, when we're studying population growth, demography is the study of the characteristics of populations, specifically human populations. So we'll use the word demography a lot while we're talking about the study of human populations. So there's two types of countries that we are going to kind of compare and contrast in this series. And there are developed nations and then developing nations or developing countries. So developed countries, America is a developed country. We have basically higher average incomes, slower population growth, diverse industry and economies, and stronger social support systems. So what does this mean? So we have a higher income levels, but we have slower population growth. Why would this be? If in industrialized nations or developed countries, our we don't necessarily need to rely on population growth or children to affect our families' economies. Actually, specifically, it could be a hindrance to our families' economies, whereas in developing countries, they need that familial support in order to sustain their own economic advantages. We also have higher education. And so a lot of times women are in careers, and so children are actually less cost effective, and they might be a cost constraint when we're talking about paying for childcare and other services that a woman's not necessarily doing while they're in their career field. We have diverse industry, so we have lots of different occupations in our country. Um, and then stronger social support systems. So this is important if we lose a job or other catastrophic events occur, we're more likely to be able to come back from that, and it won't be as devastating to our family in a developed country as opposed to a developing country. So those are just some factors that are affect a developed country. When we're talking about developing countries, we're gonna have lower income. It's going to be more simple agricultural based, and this is where the children come in. And if in order to sustain that um, economic stability within a family, we need children to help out with these economies within a family. We also they also have more children in order to help with aging parents or taking care of other siblings. They play more of a role within the family than in a developed country. And so there's more rapid population growth within these developing countries. Okay, so before we talk about this, we're going to look at the graph on our next slide here. So this is the world population over time. And so you can see here we have domestication of plants and animals. And then as we come closer to 2000, we have very much exponential growth within the human population. Obviously, we're not going to be able to sustain that forever, but with new technologies and new ways of expanding our resources, we don't necessarily know how long we can sustain this exponential growth. So it's important to note that around this time, we have our Industrial Revolution. We have also perfected the art of domestication. So we have crops and cattle and different food resources that are more sustainable. Well, as far as feeding a large group, are more sustainable for that method. And so there are numerous factors that contribute to this exponential growth here. And so let's talk about some of those factors a little bit more in depth. So exponential growth basically started in the 1800s, and this is mostly due to decrease in death rates. So we had increase in food production. We were able to sustain a large community with our industrialization of foods. We have clean water, improvements in hygiene, safe sewage disposal, and then discovery of vaccinations. I would also put in there antibiotics is probably a big factor in that as well. So these are some of the basic components to exponential growth rate. So if we remember back in the last unit, we talked about the rate of birth versus the rate of death and how that evens out. Well, at this point, the rate of births are exponentially growing, whereas the rate of deaths are prolonged. It used to be like back in the 1800s, our life expectancy, including infant mortality, would be an average of 40 years. Now it's 80 plus. So that has a big factor concerning the human population growth over time. So there are different types of age structures. So here we have a population where it's more of a pyramid, and so this is going to be a stable growth rate here in this pyramidal structure here. So we have more young people than we do older people, so it will continue to exponentially grow, and these are going to be the least developed nations because we have a much higher growth rate than we do in the more developed nations. So a transitional nation is in between a developed and developing nation. And so transitional nation is not quite as pyramid structured. Here we have fewer children being born or children surviving. And so it's not quite as pyramidal structure as the least developed nations. But then we have the very developed nation, which is kind of stagnant. We don't have a high birth rates, so we definitely don't have a pyramidal structure. It's kind of equal. So classification of members of a population into groups by age or distribution of members of a population in terms of age groups. This is age structure. And so these graphs kind of help us make predictions on what our growth rate will be and what our population size will be. And that's what scientists kind of use, aside from immigration and emigration, to kind of establish a prediction on growth rate. So countries with high rates of growth usually have more young people. And so we see that here with this population. We have the ages of the population here, and they are much broader than the population up here in the older age range. Countries that have slow or no growth usually have an even distribution of ages in the population. So we have a slow growth in the United States, and this is what our population looks like here. So survivorship. What does survivorship mean? So the percent of newborns in a population that can be expected to survive to a given age. So this is a big predictor of population, and basically the health of a population is infant mortality rates. The higher the infant mortality rate, the lower the health of that particular nation. And it's used to predict population trends. To predict survivorship, demographers study a group of people born at the same time and note when each member of the group dies. So these are different survivorship curves within a population. And so I think it talks about the different types. So type 1, most people live to be very old. These are going to be in developed countries where the economy is high. Type 2 populations have a similar death rate at all ages. And type 3, many children die. So you can see like this will be, type 1 will be more developed. Here, let's go back. More developed nations, and then more kind of in between developed and developing, and then more developing nations here. Okay, so fertility rates. Fertility rates are the number of births per 1,000 women of childbearing age. So the replacement level is the average number of children each parent must have in order to replace themselves. So it's going to be a little bit more than 2 because not all children will survive and reproduce. So here in America, it's about 2.1. In other developing countries, the replacement level would be higher because they'd be more likely to die before reproductive age. So you can see here that we have a graph about on the replacement level. And so total fertility rate in the 1920s would have been about 3.4. And then we hit a baby boom here after a war, and we have about 3.6 is the average birth rate. Now it has gone way down, and we are actually lower than the replacement level in the 1980s, and it's kind of stayed pretty stagnant. It's just now starting to go a little bit above the replacement level. So other factors that affect population would be migration. Any movement of individuals or population from one location to another. So movement into an area is immigration. Movement out of an area is emigration. So both of these factor into our population. So you can see that birth rate still accounts for most of a population, but immigration affects developed countries in particularly. So we have other people moving into the population and increasing that population. Okay, so I'm going to stop there at this video. Again, you can watch this over and over again. Don't forget to take the quiz on this video and take your notes for class.